So getting two computers to agree on what the time is can be pretty challenging. If you ask two computers what time it is down to the millisecond, they'll usually tell you a millisecond time, and it will be off with one another by 100, 200 milliseconds or so, right? They drift from one another over time. And that's just a challenge of time across the internet. Now, Google solved this problem by basically throwing raw physics at it. The way they did it is, in each one of their data centers, they have a GPS antenna and they have an atomic clock. And the GPS antenna is there to basically sync up with what they think the time should be, and the atomic clock is there to make sure that they keep the time once they've synced up. And so, whereas a normal computer will be off by 200 milliseconds, one of these setups will be off by 5 or 7 milliseconds. And that's just basically through these incredibly precise bits of equipment they're using to keep track of time. But you're still not right, you still don't have the exact time, and if you want to create an exact chronological sequence of events where you say, okay, this event definitely happened after this timestamp, you're still in a bit of a bother. So what they do on top of that is this concept called commit wait, where they say, hey Google, what's the time? And they get back this time window, which is 5 milliseconds large, where they were kind of saying, we know the time is definitely between this timestamp and that timestamp. And then they just wait until the end of that timestamp, and they say the end of that time period that we've got, the event definitely happened after that timestamp, so we can use that endpoint as our timestamp. And so that's kind of how they get this precise timing for things. Cheers.